You know, when we think about AI, we usually picture this one super smart brain, right? Like a single genius cracking a code. But what if the real revolution, the next huge leap forward in science, isn't about one AI at all? What if it's about getting a whole team of them to work together perfectly? That's what we're diving into today. This massive shift from a solo act to, well, a full-blown orchestra of intelligence.
Okay, but before we get ahead of ourselves and talk about the future, we gotta ground ourselves in the present. And right now, the present is dominated by this one enormous problem. Why is it so ridiculously hard, slow, and expensive to find new medicines? I mean, it's one of the biggest challenges we face. It's like a puzzle with literally trillions of pieces, and honestly, we're just struggling to even get all those pieces out of the box.
All right, so here's how we're going to break it all down. First, we'll look at the crisis of complexity. Then, the eye-watering cost, we're calling it the $60 billion bottleneck. After that, we meet the hero of our story, the AI conductor. We'll check out the amazing results under power, speed, and scale, see how this all makes money in the intelligence economy, and then wrap up by looking at the future of discovery. Let's jump in.
Okay, first up, the crisis of complexity. So let's get right to the heart of the problem. When you picture medical research, you probably think of these clean, quiet labs, right? Well, scrap that. The reality is more like a hurricane of data. You've got genomics over here, clinical data over there, proteomics. It's just this massive storm of information, and even our smartest people, with the best tools, are basically just trying not to get swept away.
And here's where we can really see what's going on inside that storm. It all breaks down into a few key challenges. First, you've got these analytical silos. Think of it like this. The team studying genes doesn't talk to the team studying proteins. They're in different buildings, speaking different languages. Then, you've got humans trying to bridge these gaps, but it's all manual, which is super slow, and people make mistakes. Plus, there just aren't enough specialists in the world to connect all these dots, and our computers, they just can't handle the sheer scale of it all. So what's the end result? A total mess. You get inconsistent, unreliable results. It's like having a bunch of genius musicians all playing different songs at the same time. It's just noise, not music.
So, all this chaos, what's the price tag? Because this isn't just some abstract academic problem. Oh no, this is a huge, multi-billion-dollar bottleneck, and it's physically stopping the entire industry from finding cures faster.
Get ready for this number, because it's a big one. Over $100 million. Now hold on, that's not for the whole industry. That's how much a single big pharma company loses every year, just because of these coordination problems. Just think about that. That's $100 million that could be going into creating life-saving drugs, and instead, it's just, poof, gone. Wasted on pure inefficiency.
And this right here is why all that money is disappearing. 80%. That is the estimated failure rate for complex analytics that try to pull data from multiple sources. Can you imagine that? You pour millions of dollars, countless hours of work into a project, knowing it has an 8 out of 10 chance of just failing completely. That's the brutal reality today. Most of these ambitious projects just collapse under their own weight.
But here's the flip side, and it's a big one. A problem this huge, well, it creates an equally huge opportunity. If someone could actually build something to fix this chaos, to get real, coordinated results, the market for that solution is estimated at a staggering $60 billion. That's the prize waiting for whoever can crack this nut.
And that, of course, brings us to the solution. And we're not talking about just another clever app or a slightly faster algorithm. No, this is a whole new way of thinking. It's a new kind of intelligence designed specifically to tame that complexity. You could call it coordination intelligence. It's AI that doesn't just analyze, it conducts.
So the core tech here is called a multi-agent pipeline. And the definition is right there. It's a system that orchestrates multiple specialized AI agents. That word, orchestrates, is everything. It's the key. See, it's not enough to have a bunch of smart AIs. You have to get them to work together, to play in perfect harmony.
And to really get this, let's use an analogy. It's actually perfect. For a minute, just forget all the tech jargon. Instead, I want you to picture a world-class symphony orchestra.
Now, in this orchestra, every musician is a genius, an absolute virtuoso. So one AI is like the world's greatest violinist, and its instrument is genomics. Another AI is a prodigy on the piano, and it plays clinical trial data. A third is a master of the cello, specializing in proteomics. You get the idea. Each one is an incredible expert on its own.
But what happens if you just stick all those geniuses in a room and say, okay, play? Well, you get chaos, you get noise, you get that 80% failure rate we were just talking about. All that amazing individual talent is just wasted because there's no coordination.
And this is where it all clicks. The multi-agent pipeline. That's the conductor. The conductor doesn't play an instrument. Its job is to know the strengths of every single musician, to hand them the right sheet music at exactly the right moment, and to bring them all together to create something beautiful and powerful, a symphony of insight.
Okay, so we get the concept, right? The AI conductor leading the orchestra. But what does that sound like? What are the actual results when this symphony starts to play? Well, to put it mildly, they are absolutely game-changing.
I mean, just look at this comparison. It's a complete night and day difference. The old way? Slow, expensive, totally manual, everything stuck in its own little box, leading to that crazy high failure rate. The new way? It's fast, it's efficient, it's automated. Everything works together, which means the success rate goes way, way up. It's a whole new ballgame.
And this is where the numbers just get kind of nuts. We're not talking about a small improvement here, like 10 or 20%. We're talking about a 500 to 1,000 times increase in analytical power. That's not an upgrade. That's like trading in your kid's magnifying glass for the Hubble Space Telescope. The leap is just massive.
And it's not just about power. Look at the efficiency gains. You're slashing the time it takes to get answers by 70 to 90%. You're cutting costs by that same huge margin. And you need way fewer of those super specialized expensive human experts to manage it all. But here's the crazy part. While all that's happening, the quality of the results actually goes up by 300 to 500%. Think about that. It's faster, it's cheaper, and it's better. That's the trifecta. That's how you revolutionize drug discovery.
So, when you can deliver results like that, it's not just a scientific breakthrough anymore. You've just created an entirely new business model. Welcome to the intelligence economy, where you're not just selling a tool, you're selling the service of conducting the orchestra.
So how do you actually make money off this? Well, there are three main ways. First, you can license the platform. You're basically selling companies the conductor's podium and all the sheet music so they can run their own shows. Second, you can offer coordination as a service. This is like renting out your world-famous conductor for special projects. And third, you can build custom AIs. This is like scouting and training a new star musician for a very specific, tricky piece of music that no one else can play.
And what's so smart about this is that the value is super clear for everyone involved. For a huge pharmaceutical company, you're getting 1,000 times more power for a fraction of your current cost. It's a no-brainer. For smaller biotech startups, you suddenly get access to elite tools that you could never dream of affording on your own. And for research universities, you're handing them a massive competitive advantage to make the next big breakthrough.
All right, so this brings us to the big picture. Where is all of this heading? Because when you have a tool this powerful, you have to start thinking about the long-term implications. We're not just talking about making research a little faster anymore. We are talking about the potential to do things that, until now, were completely impossible for humans to even attempt.
And this quote really just sums up the whole ambition here. The goal isn't just to build a helpful assistant for scientists. The ultimate goal is to create a system whose analytical power can match, and then maybe even surpass, an entire team of the best human experts on the planet. I mean, wow, that's the endgame.
So that leaves us with one last, massive question to think about. We've just explored a system that can organize genius on a scale that's literally superhuman. So what does science look like when the process of discovery itself becomes autonomous, when it's driven 24/7 by a tireless, flawless symphony of AI? What kind of cures, what kind of breakthroughs are out there, just waiting for this new kind of orchestra to play them?